Okay, good morning, dear students. This morning, we will learn about the derivatives of the exponential and logarithmic functions. Before we get into derivative formulas for the exponential and logarithmic function, let's first review some of the properties or rules on exponentials or your laws of exponents. Okay? So the following are the exponential rules. Product rule: when we multiply powers of the same bases, we copy the common base and add the exponents. For example, a squared times a cubed is equal to a to the fifth power. Quotient rule: when we divide powers of the same bases, the rule says we simply subtract their exponents. Okay, so here, by the way, a raised to x, a is the base, and x is the exponent. That's why we call it exponential. Exponential function because the variable x acts as an exponent. Okay? Compare and contrast between 2 raised to x and y is equal to x squared. Okay, this is your quadratic function or polynomial function. Okay, quadratic because x is raised to the second power. X is raised to the second power. So, x acts as a base. Whereas for exponential functions, okay, for an exponential function, the variable x, okay, the variable x acts as an exponent. Okay, so that's how to distinguish between your polynomial functions and your exponential functions. Okay, so when is it exponential? When the variable x acts as an exponent to a specific constant. So for example, 2 raised to x. So moving further, what did we say? Quotient rule. If we divide two powers with the same bases, we simply copy the common base and subtract the powers or the exponents rather. Okay? For example, a to the 7th divided by a to the 4th or a to the 3rd is simply a to the 7 minus 3 a to the 4th power. Next, we have power rule. Raising a power to an exponent or to a power. A raised to x raised to y, the rule says we simply multiply the exponents. Okay? So, a raised to xy. And then, example, a raised to 7 raised to the second power is equal to a raised to 14 from 7 times 2. Next, okay, the negative rule, we can express a raised to a negative exponent, a raised to negative x, into 1 over a raised to x. Okay, this is very important, most particularly when you will be asked to simplify or differentiate functions like 1 over e raised to x, 1 over the square root of x, and so on and so forth. Okay? For example, a raised to negative 4 is 1 over a to the 4th. And the zero rule, okay, a raised to 0 is equal to 1, except for 0 raised to 0. Okay? So those are the rules. or should I say the laws of exponents. We can also call this your laws of exponents. Laws of exponents from your basic math. Laws of exponents or exponential rules. Therefore, we have then two types of your exponential function. Okay? That having a base e, that whose base is e, okay, base e and base a. So this morning, we shall look into the two different forms or two forms rather of your exponential functions. E raised to x when the base is e and when the base is a. Okay, e here is the natural number. If you have your calculators with you, if you press shift natural logarithm of 1 and you'll get 2.71828, something like that. That's the approximate value of e. E is also an irrational number. Okay? So, e raised to x and a raised to x. So, if the function is e raised to x, its derivative, okay, the derivative with respect to x of e raised to x is e raised to x itself. Okay? E raised to x. However, if the exponent, okay, if the exponent is a differentiable function represented by u, okay, e raised to u, then y prime, or the derivative, I should say, derivative with respect to e or with respect to x of e raised to u is equal to e to the u times derivative of u with respect to x. So if the exponent is no longer x, it's no longer x, but a differentiable function in x, let it be represented by u, then derivative is e to the u times du. E to the u times du. So this is the first form, okay? If the base is e. In fact, this could be e to the x ln of e. But, okay, but ln of e, let me write here, but ln of e is equal to 1. Okay, please take note of this. But the natural logarithm of 1, of e rather, is equal to 1. So this one is reduced to e to the x. Because anyway, ln of e here is equal to 1. Okay, so we don't have to write it. I'm going to erase it now. Now, what about if the base is a number other than e? For example, 2, 5, 10. Then that takes the form a to the x. Okay? A to the x. So if your function has the base a, then its derivative is a raised to x ln of a, the natural logarithm of a. A to the x, the natural times the natural logarithm of a. Now, if the exponent is no longer x, but a function in x, okay, a function in x, let it be represented by u, then the derivative of a to the u with respect to x is a to the u times the natural logarithm of a times du by your chain rule. Okay? So we still have to get the derivative of u with respect to x. Okay? So for e to the x, its derivative is e to the x. For e to the u, it's e to the u times du. For a to the x, it's a to the x times the natural logarithm of a. And for a raised to u, where u is differentiable, then it is a to the u times the natural logarithm of a times du. Okay, let's look into some applications. Okay, number 1. Find y prime if y is equal to, y is equal to 2 raised to x. Okay. So, looking at the given, y is equal to 2 raised to x. So, obviously, this is of the second form. Okay? It belongs to the second form because its base is 2 and not e. So, this one is of the form a raised to x. Okay? E raised to x. So, simply differentiate this by applying the rule. Y prime is equal to, okay, what did we say? If it takes a to the x, it's simply a to the x times the natural logarithm of the base. So, simply 2 raised to x times the natural logarithm of 2. Okay, that's it. How about number 2? If we have, okay, if y is equal to 1 over, okay, how about this? If y is equal to 1 over x, find dy over dx or y prime. Okay? Okay, how shall we simplify this? Remember from our review of the rules a while ago, or laws of exponents? Let me include that. From our laws of exponents, the rule for the negatives, ayan, the rule for the negatives, this one. So, let me highlight. Okay. Yan. 1 over a raised to x could be written as, okay, a raised to negative x. So, I could rewrite the given into e raised to negative x. Okay? So, y equal to 1 over e raised to x is in fact y equal to e raised to negative x. Okay, so what is y prime? Okay, so the second falls under the first because the base is e. Okay, the base is e. Okay, so y prime is, and since the exponent is negative x, by the chain rule, we have to differentiate, okay, negative x. So y prime is equal to e, yan, e to the u, let me highlight, yan, e to the u times du. So e raised to, why am I using red? E raised to negative x times the derivative of negative x, okay, from your chain rule is negative 1, okay, negative 1. Or, how else can we write this? Y prime could now be written as negative 1 over e raised to x. Okay, so this is our final answer. Now, we proceed to the next problem. Number 3. How about if you have Why? So let's combine our previous formulas from our algebraic differentiation, chain rule, power rule, quotient rule, sum difference, and then trigonometric and inverse trigonometric function. Find f prime of x if f of x is equal to sine of e raised to x. Okay. So what is f prime of x if the function is f of x is equal to sine of e raised to x? Okay, let me write the function given here. F of x is equal to sine of e raised to x. Okay, so looking at the given, we have trigo and expo. Okay? The given, in fact, is a trigonometric function, sine of u. Okay, sine of u. However, our u, the argument, our u is exponential. Okay? So, differentiate using trigonometric function, and from chain rule, we differentiate the e to the x using exponential differentiation. So, going back, recall, what is the derivative of sine? Okay, derivative of sine is cosine. Okay, so f prime of x, therefore, is equal to cosine u du. So, cosine of e raised to x times, by our chain rule, differentiate e raised to x, e raised to x. So, as simple as that. Okay, or you can rearrange the factors into e raised to x cosine of e raised to x. Okay, now moving on to number 4. Okay, problem number 4. What about if you have y is equal to e raised to cosine x sine x? Okay, find y prime. Okay, find y prime. What should we do with this? Y equal to e raised to cosine x sine x, and then you have to find y prime. Okay, so let's examine the given. The given is e raised to u, where u is cosine x sine x, and in fact, it is a product of cosine x and sine x. Okay, so in here, we will apply both derivative of an exponential function, e to the u, and the product rule plus trigonometric functions, because the involved, or the factors involved in our product are trigonometric functions. So here, your function takes the form e to the u. Okay, the function takes the form e to the u. So our y prime must be e to the u times du. However, our u here is the product of cosine x and sine x. So, u is cosine x sine x, which is a product. So, what then is du? What is du equal to? Recall from your algebraic differentiation, the product rule, the first times derivative of the second. So, the first. Which one is the first function? Cosine x. So, cosine x times derivative of the second, derivative of sine is cosine x, plus the second is sine x. Wala tayong space. Once more, du equal to the first is cosine x times derivative of the second, derivative of sine x is cosine x, plus the second, which is sine x, times derivative of the first, which is negative, okay, negative sine x. Okay, so let's continue further. Du will now be cosine squared x minus sine squared x. So let's go back to the original function. So your y prime, okay, sige. Y prime is equal to e to the u times du. Okay, so e raised to cosine x sine x times this. However, from your identities, cosine squared x minus sine squared x is equal to, one double angle formula, which is cosine 2x. Okay, so we could simplify this as du equal to cosine 2x. Okay, so may we use this as our du. Okay, to simplify it. So times our du is cosine 2x, and that's it. Okay, so the answer is e raised to cosine x sine x times cosine 2x. Now we proceed to number 5. Okay, unless there are questions. Okay, cosine 2x. Now we proceed to problem number 5. How about find dy over dx if e raised to x over y ay paano naging cosine 2x sa identities, anak? From your double angle identities. Okay, from your double angle identities. This one. Cosine of 2x is equal to cosine squared x minus sine squared x. Okay, from your double angle identities. Remember the identities that we have reviewed before? Pythagorean, reciprocal, half angle, double angle, sum, and difference. Okay, product identities. So please go over. But if you stop with this, if you answered e raised to cosine x sine x times this, it's all right. Okay, it's all right. Now we proceed to the next. How about if the given is an implicit function? E raised to x over y is equal to x squared, or x rather, plus y squared. Find dy over dx if e raised to x over y is equal to x plus y squared. Okay? So, this is an implicit function. So, we have to make use of implicit differentiation. Now, looking at the left and right side of the equation, this side is of the form e to the u. Okay? And this is simply a sum of two. Okay? Differentiate the first and then differentiate the second. Okay, so let's differentiate first e raised to xy. Okay, e raised to x over y takes the form e to the u. So to differentiate, we apply the rule e to the u times du. Okay, so e raised to, however, take note of our u, of our exponent. It's a quotient. Okay, that means we have to employ quotient rule. So, let's continue. Getting the derivative now of e raised to x over y times du. Derivative of this. Derivative of x over y, which is a quotient, is, okay, what's the derivative of a quotient once again? The denominator y v du, okay, minus u dv. Denominator y times derivative of the numerator, derivative of x is 1, okay, v du minus u dv. Take note of that, huh? v du minus u dv, or denominator times derivative of the numerator minus the numerator. Our numerator is x, okay, minus x times derivative of the denominator, which is dy over dx, all over the square of the denominator, which is y squared. I hope you can follow. So we're done with the left side. We move on to the right side. So we differentiate term per term because anyway this is a sum. The derivative of x is 1 plus the derivative of y squared, okay, is derivative of y squared is 2y dy over dx. Okay. Now, since this has a denominator of y squared, okay, let's simplify from here. We can get rid of y squared by multiplying both sides by y squared. Right away, multiply. Let's multiply both sides of the equation by y squared. Okay, by y squared because I want to eliminate this already. This will now be eliminated, giving, okay, so making it, multiplying this also with this, and with this, what do we get? Multiply e raised to, let me highlight, this multiplied to y and this multiplied to this. What will that be? That will give, okay, y e raised to x over y, okay, minus, okay, x e raised to x over y dy over dx, okay, equals, since we multiplied, okay, let me highlight once again, the whole by y squared, multiply it by this, and multiply it here. Okay, so what do we get? Y squared, I should say. Y squared plus 2y cubed dy over dx. Okay, so now we collect terms having dy over dx on one side of the equation. So I could, okay, move this to the other side. Let's use this, okay. So let this one remain here. Okay, so it will be y e raised to x over y and minus y squared. I'm going to move, okay, y squared to the opposite side. This here and this one here, giving, okay, minus y squared is equal to, okay, x e raised to x over y plus 2y cubed dy over dx. Okay? X e raised to y plus 2y cubed. And then finally, getting rid or isolating dy over dx, we can now divide both sides of the equation by this. Let me just copy first. Okay, y e raised to x over y minus y squared equal to the quantity x e raised to x over y plus 2y cubed, okay, dy over dx. Then divide the whole equation by this. X e raised to x over y plus 2y cubed. Okay? X e raised to x over y plus 2y cubed. Then this now will cancel out. So finally, we can write our answer as dy over dx is equal to y e raised to x over y minus y squared all over, okay, all over x e raised to, sorry, y cubed. This is supposed to be x. Okay, tama. X e raised to y. X times e raised to x over y plus 2y cubed. This is supposed to be an exponent. So let me write it properly. X over y. Okay? Why, anak? What happened? Okay, just stay out downstairs. Okay, so the final answer is this. Now we move on to the next. Are there questions at this point? Now we move on to problem number 6. How about if you have y is equal to square root of e raised to x plus e raised to the square root of x. Okay. So, for number 6, how shall we simplify this? E raised to, or the square root of e raised to x plus e raised to the square root of x. Again, applying your laws of exponents, express this as y equal to, this is e raised to x raised to 1/2. Yes? Raised to 1/2. And this, the other term, is e raised to square root of x. Leave it that way. Or x raised to 1/2. Okay, take note that they are different. This is e raised to x raised to 1/2. Okay, so now we differentiate using e to the u and GPR, chain rule. Okay, because this takes the form u raised to 1/2, u to the n. So apply your generalized power rule for the first term. And the second term, apply e to the u. Okay, so what will y prime be? Y prime will be equal to y prime will be equal to, the first term takes the form u raised to n. So we have to apply our generalized power rule. Okay, we bring down the exponent 1/2. Okay, so it will be 1/2, okay, times e raised to x raised to negative, okay, negative what? Negative 1/2 times derivative of e raised to x, or, okay, now before we apply that, let's simplify first. Okay, it would be simpler, may I erase? It would be simpler if we apply the laws of exponents here. Okay, otherwise our solution would be complicated. Okay, again from your laws of exponents, let me just show laws of exponents and dito. Ayan, okay, this one. I want you to look at this. Okay, so a raised to x raised to y is simply a raised to xy. So we apply that here. E raised to x raised to 1/2 is simply e raised to 1/2 x. Okay, that makes it simpler. Okay, plus e raised to x raised to 1/2. So we simply make use of e to the u for both. Okay, so y prime then is equal to e raised to u 1/2 x times du, derivative of 1/2 x. The derivative of 1/2 x is 1/2. Okay, plus, or times 1/2 rather. Plus, okay, again, this takes the form e to the u, so e to the u times du. Its derivative will be e raised to x raised to 1/2 times, okay, derivative of x raised to 1/2, or the square root of x, by our power rule is 1/2 x raised to negative 1/2. Okay, 1/2, bring this down, times x raised to 1/2 minus 1 is negative 1/2. Okay, so let's simplify it further. Y prime will now be 1/2, and then what's the other way of writing this again? Okay, e raised to 1/2 x is square root of e raised to x. So instead of having e raised to 1/2 x, I can now write it as the square root of e raised to x. Plus, okay, plus, yan, 1/2, 1/2, e raised to x raised to 1/2 is e raised to the square root of x. Sorry, the space is not sufficient. E raised to the square root of x, that's this one. And where did I get 1/2 from here? And then since this is x raised to negative 1/2 from your negative rule, I could bring it down to the denominator. So over the square root of x. Okay, so this is the final answer. The final answer is y prime is equal to 1/2 of the square root of e raised to x plus e raised to x all over 2 square root of x. So since 1/2 is common to both, you can factor it out or leave it that way, it's alright. Okay, or y prime is, okay, the square root of e raised to x over 2 plus e raised to the square root of x over 2 square root of x. Okay? Are there questions at this point? How about for if the base is E or A rather? Let's look at example number 7. Okay, if y is equal to 5 raised to tangent x, find y prime. Okay? If y is equal to 5 raised to tangent x, find y prime. So obviously, this one is of the second form because its base is 5 and not e. So what will y prime be? Y prime will now be from here is a to the u times the natural logarithm of a times the u. Okay, so y prime will be 5, a to the u, that's your a is 5, your u is tangent x. Okay, ito, a to the u. Natural logarithm of the base, your base is 5, so times the natural logarithm of 5 times this from your chain rule times the derivative of this. Okay, go back again to your list of derivatives for trigonometric functions. Derivative of tangent x is, okay, secant squared x. Okay, so that's it. A to the u, let me write that in red ink. A to the u times the natural logarithm of a times the u. Okay, so a to the u times the natural logarithm of a times derivative of the exponent tan, which is secant squared x. Okay, I think this is clear. How about number 8? Let me check the time. Your quiz will open at exactly 10:10, but I could open it at 10 o'clock. If you could finish all of the problems I have prepared for this morning, then you can take it ahead of time. Okay? It's only good for 15 minutes. 10 items, true or false, and 1 item open-ended. So for submission of answers for the open-ended, you can write in a piece of paper, take a photo, and submit. Okay? Or if you can encode, up to you. It's up to you. But piece of answers written on piece of paper, it's all right. Just take the photo and submit it to TrueLens. Number 8. How about if g of x is equal to okay, 5. Let me change it into another base. I'll change it into, let's say, 3 or 10. Okay? So if you have one like this, g of x is equal to 10 e raised to x. 10 raised to e raised to x. Or let's make it even 2x. Okay. So, take note rather that this is of the second form still. Here, a to the u. Okay? A to the u, where u is another exponential function, e raised to 2x. Okay, so let's apply again the rule or the formula for a to the u. Okay, for a to the u, this is the formula. Okay, so your g prime of x is equal to a to the u natural logarithm of the base times du. So 10 raised to e raised to 2x times natural logarithm of 10 times. Okay, take note that this is our u. Okay, here is our u. Our u is e raised to 2x. So to differentiate it, apply the rule e to the u du. So e raised to 2x times derivative of 2x, which is 2. So our du then is 2e raised to 2x. So times, let's continue. This is now our a raised to u. Ito, a raised to u. This is ln, the natural logarithm of a, and then times du, which is 2e raised to 2x. 2e raised to 2x. Okay? Or g prime of x, you can rearrange, but if you leave your answer in this manner, it's alright. It's okay. This is alright anyway. May I enclose it in a rectangle? That's alright, or you can arrange. Anyway, we cannot put this together. Okay, you cannot put this together because the bases are different. This has a base of 10 and this one is 2e, so we can't. Okay? Or you can simply rewrite this into g prime of x is equal to, okay, this we could put together 2, I could write it as 2 times the natural logarithm of 10 times e raised to 2x times 10 raised to e raised to 2x. And further, we can simplify this from your laws of logarithms. Ito could be simplified as g prime of x, okay? G prime of x is equal to the natural logarithm of 100 times e raised to 2x times 10 raised to e raised to 2x. Where did I get 100? From your laws of logarithms. Let me write here. From laws of logarithms. That n log of b is equal to logarithm of b raised to n. What becomes of the factor n? N here could become a power of the base. Okay? N becomes a power of the base. So, if I have 2, and then it becomes an exponent of 10, 10 squared is 100. Okay? Or if you ended up with this, what did I say? If this is your end point, it's alright. This is already correct. Okay, this is already correct. Are there questions at this point? The last two problems. Okay, problem number 10. Problem number 9, I should say. Problem number 9. What if we have e raised to y is equal to e raised to x cosine x? Y equal to e raised to x cosine x. And the last, may I just write number 10? Number 10, our number 10 will be y is equal to x e raised to x all over 1 plus e raised to x. Okay, let's answer together number 9. So to give you time to review also. It's 9:26. It will not take much time anyway. Okay, so for number 9, again, this takes the form rather e to the u. So its y prime will be e to the u times du. Okay, so let's answer this now. Y prime will now be e raised to x cosine x times du. Okay, times du. However, our u is x cosine x. Okay, so what then is our du? Take note that again, this is a product. Okay, the first, x, times derivative of the second is negative sine x. Okay, plus the second, which is cosine x, times 1, derivative of the first. Okay, so let's simplify further. Du is equal to negative x sine x plus cosine x. So let's put that here, times negative x sine x plus cosine x. So as simple as that. Okay, so that's it. E raised to x cosine x times negative sine x plus cosine x. Let's enclose this in a rectangle. That's it. Okay, if you ended up with this, it's alright. No problem. This is already correct. Okay, and the last one, number 10. Okay, how about y is equal to x, okay, x e raised to x all over 1 plus e raised to x. Take note of the given. It takes the form u over v. So it is a quotient. Okay, it's a quotient. Wherein your u, let me highlight or let this be u and let this be v. Recall once again that if your function takes the form u over v, again from our quotient rule, y prime is v du minus u dv all over v squared. Okay, so y prime will be, what will y prime be? Y prime will be equal to, okay, v, okay, v in the rule says v, which is our denominator, the denominator which is 1 plus e raised to x times du, derivative of the numerator. However, our numerator is a product. Okay? So to differentiate our numerator, okay, we have to apply the product rule. And the product rule says the first, okay, the first, that's x, times derivative of the second, derivative of e to the x is e to the x itself. Okay, e to the x plus the second, which is e to the x. Okay, the second is e to the x times derivative. Okay, derivative of the first, which is 1. So times 1. Okay? So, we're done with this. Ito yung ating v du. V du. Moving on. Minus u dv. U is this. Okay? So, enclose it in a pair of parentheses. X e raised to x times dv. Okay? Derivative of the denominator. Okay? Derivative of 1 is 0, so I don't have to write that. And derivative of e to the x is simply e raised to x. Okay? But we're not done yet because we have the denominator v squared. Okay? All over v squared, which is 1 plus e raised to x raised to 2. Can you follow? Hope you can follow. Again, this is v du minus u dv over v squared. Or denominator times derivative of the numerator minus the numerator times derivative of the denominator all over the square of the denominator. Okay, let's continue simplifying. Okay, what will y prime be? Y prime will be equal to, okay, let's see what's going to happen. X, multiplying it with this by applying your distributive property. We have a binomial times a binomial, this with this with that. Then we'll get x e raised to x and then plus e raised to x plus e raised to, multiply this, wait, let me highlight using another color. This with this and this with the second. What do we get? X, okay, plus, let me use, okay, plus x, okay, e raised to, okay, what is e? Note, let me write that. Note, e raised to x times e raised to x. What is it equal to? What did we say? When you multiply powers of the same bases, copy the common base and add the exponent. So, 2x. So, ito will give e raised to x times e raised to x will be, okay, e raised to 2x. X e raised to 2x. And then e raised to, okay, and then this one will also give plus e raised to 2x. Where did I get e raised to 2x? From here. E raised to x times e raised to x. Now we proceed to the next. You have minus x e raised to 2x. Why did I erase it? Okay, x all over, okay, the quantity 1 plus e raised to x raised to 2. Are there terms that we could cancel out? I think we could cancel out this. Okay, and this. So what will remain in our numerator? Our numerator will have x e raised to x plus e raised to x plus e raised to 2x all over 1 plus e raised to x squared. Okay, you can leave your answer this way or you can express the numerator in factored form, but this is already alright. Okay, or like what I said, you can factor it out since e to the x is common to all the terms above. Then we could express it as, okay, e to the x times x plus 1 plus e to the x. Okay? That's after factoring this out. Factor out, factor this out, factor this out. What will remain here will be x, will be 1, and then 1 e to the x. All over, sorry, should be black. All over the quantity 1 plus e raised to x squared. You don't have to expand the denominator. But if you ended up with this, it's alright. This is already correct. Are there questions at this point? Okay, number 9 and number 10. I think I did not give you one for inverse trigo. Okay, one last because I did not give you one for the inverse trigo function. Now recall from your laws of or the rules for differentiating inverse trigonometric function that the derivative of arc tan u is du over, if your function takes the form arc tan of u, then y prime is equal to, what did we say about derivative of arctan? Arctan is equal to, arctan of u is equal to, for arctan of x is 1 over, let me see, du over, it's du over, okay, 1 plus u squared, okay, du over 1 plus u squared. Okay, so in this case, your u is 2 to the x. Okay, so let u be equal to 2 raised to x. Okay, you're right. Du over 1 plus u squared. And du is equal to 2 to the x, the natural logarithm of 2. Okay, so let's answer this now. Y prime equal to, from the rule, yan, du is this. Okay, so simply putting this into our formula, y prime will now be du is 2x, 2 raised to x rather, times the natural logarithm of 2 all over, okay, 1 plus, okay, u squared, then this is your u, wait, okay, our u is 2 raised to x, so plus 2 raised to x squared. Or simply y prime equal to 2 raised to x times the natural logarithm of 2 all over 1 plus, okay, 1 plus okay, 2 raised to 2x. Or if you ended up with this, it's alright, no problem. This is already correct. Are there questions at this point? If there are no questions, then we could end up the session and you can review for a few minutes, and at exactly 10, I think I've set the quiz at 10:10 and it's good for 15 minutes only. I gave you one function on exponential. Exponential with base e. Okay, base e lang. Simplify this. Okay. Okay, wait. Over. In fact, here, 2 raised to 2x is same as 4 raised to x. Okay? 4 raised to x. 4 raised to x na lang. Did I answer your question, Jeric? Because I could express this, look at this. If I simplify this, it becomes 2 squared. Okay? Raised to x is 2 raised to 2x. Okay? Is this clear? I hope this is clear. Look. Did I answer your question? Ito, look at this. Okay? Again, remember, a raised to x raised to y. A raised to x raised to y is simply a raised to multiply the powers x, y. So if you have 2 raised to x raised to 2, adi 2 raised to 2x, but in fact, this is 2 squared. Is in fact 4 raised to x. Okay? Is that clear? Is it clear? Okay? Or if you want, you can end up with this. It's alright. That's why I encircled this, because you might get confused with the next step. So this is alright. This is okay. Or you can end up with this. Okay. So that ends our session for this morning. So you have 16 plus 10, 26 minutes to review. So purely the first 10 items are on the rules. Okay? Rules for trigo, for inverse trigo, for your algebraic differentiation, and one 5 points, one open-ended for 5 points. Okay, on exponential function with base e. O, sinabi ko na, base e. Base E lang. Okay? So if there are no questions, then we could end up the session now. And you can log into your Lens or review first before you log in, because there is no second attempt. Okay? Once lang yung pwede nyong i-open. And prepare with you your pencil and or pen and paper. Any type of file is accepted anyway. So, JPEG pwede, picture pwede, screenshot pwede. Okay? Okay then, goodbye and see you in lengths